Hello, everyone, and welcome to our first live event on LinkedIn. I'm so happy to see you all here, and thank you for being here today with us. I'm 𝗂𝗲𝗏𝗀. I'm a content manager at TechTrain, and I'm here today to assist you and Robertino throughout this event. Okay. And I hope this webinar will be both informative and inspiring for us. Okay, let's start with the webinar flow. First, we start with who is TechTrain, who we are, and what does this webinar cover. It takes 5 minutes approximately, and then Robertino will discuss serverless computing, the state of the art, its impact on cloud-native development, and best practices. His presentation takes approximately 45 minutes, and then we will have a question and answer session, and it also takes 15 minutes approximately. And at the final, we will make a special surprise announcement for participants, especially for you guys. And it also takes 5 minutes, and we are planning to cover everything set in 70 minutes in total. Okay, let's start to introduce ourselves. Who we are. We are TechTrain, a training and consulting company based in Switzerland. Okay. And let me continue. Just check everything is here or not. And just a second. Okay. Yeah, I guess we can continue. Okay. Again, we are TechTrain, a training and consulting company based in Switzerland, and with a broad range of expertise in areas like 𝗬𝗍𝗄𝗵, SAFe, cybersecurity, IRAP, and many other IT topics. We focus on delivering high-quality training and consulting. We develop customized solutions that are precisely tailored to our customers' needs. And our team of passionate licensed experts like Robertino has provided comprehensive training to over 30,000 professionals worldwide, helping them achieving their desired certifications. And let me introduce Robertino with you. Robertino is an instructor, consultant, and software architect specialized in cloud technologies. He studied computer science at the University of Hamburg and has spent 18 years in the IT sector. And currently he works on software quality and design at 𝗍𝗲𝗏 and advises various ministries and states on their IT projects. And let's see what we're gonna talk today in our online webinar. Under the title Serverless Computing, Robertino will explore the latest advancements in serverless computing technologies and their impact on cloud-native development and the best practices. Okay, now it's time to hand over the stage to Robertino, and we will try to answer all your questions in the question and answer session following his presentation. So you can write your questions during the presentation, and I will collect all the questions, and then we will have time to answer them. We will answer almost all questions as much as we are possible. Okay, and here we go. Hello, Robertino. You're on the stage right now. How are you?
Thank you.
Okay, if you want, you can start whenever you want. If you get ready, I can share. Okay. Yep.
So, hello everybody and welcome to the webinar regarding serverless computing. As Ashley already told you, I'm a trainer by TechTrain, and my advanced level course about cloud computing. I have already trained about 170 software architects. And I always take the chance to ask them if they are already using serverless computing in their current project. And they most deny, but some of them do. it in a successful way. And my practice and exercises and experience in that field and the discussion with that people, they already using serverless computing is the base for that webinar. So let's start. So an introduction, what is serverless computing? What's the meaning of it? Architecture pattern, different forms of serverless computing, AWS serverless, so an example of a public cloud provider, Knative as an example for cloud agnostic serverless paradigm, and some thoughts about serverless computing, a quintessence at the end of that presentation. So what is serverless? The current status of Azure, AWS, Google, and open alternatives, architectures, when do you use it and why? So one first hint is costs grow as the project grows. So if you like to use serverless computing to reduce costs, you can do this because the most of the time you are using it to scale down, only to use resources you need for your project, your architecture, for your workload. But you should keep in mind that backing services like databases and messaging systems are still alive and you have costs on that area. So be careful with that. So what do you need to be taken into account if you are using serverless approach? Actually, the first things are everything like a normal microservice architecture, allowed container-based services provided by Kubernetes, for instance. So you have to consider security, you have to consider testing, specification regarding resources. So this should be one area where you could be more relaxed if you are using serverless paradigm, but I think you should also have in mind what kind of request, how much request, it's birth request. So I think it's not a good idea to handle your architecture or your project without thinking about the resources you need in the first place. Logging and tracing is also very important because you deal with a highly distributed system, like a microservice architecture, but now with the serverless paradigm, and it's even harder to figure out what is the current state of your system. So be careful also with this. So orchestration, choreography, Saga, these are also better. I don't go deep into that paradigm because it's a webinar for itself. But if you like to use serverless computing, maybe you have a look at these paradigms too. You should also use domain-driven design, especially the strategic pattern, and here to mention the bounded context. So you're not you have to figure out what is your system on the business side, and so we deal with some technical details if you are using serverless technologies, but the business is also very important. So this should be the first step if you create an architecture. What is the actual market success of serverless computing? So as I told you in the beginning, the most of the people I talk to, they don't use serverless computing, but some do, and they do it in a successful way. And so currently it's not too high, but I think maybe we'll see that in the future because it has its own high potential if you use this in the right way in our architecture. So if you try to figure out where at the AAS topologies function or serverless computing is located, it's located at the backend as a service side and function as a service side. So we have a highly abstraction from the infrastructure and operation system and so on, and even from the container side in the most of the parts. The definition of serverless computing. There are some definitions. This definition is not especially a serverless definition, but I think it's very important because AWS in the white book, they describe stop guessing capacity planning. So just build an architecture, a system which is agnostic, which can handle all kind of requests and bursts and workloads. But yeah, once again, maybe it's a good idea to have something in your mind, but you can create an architecture which is able to deal with a lot of different kinds of workloads and request patterns. So stop capacity planning is one thing Cloud Native wants to fulfill. It's a promise to you. You don't have to deal with that anymore, because the cloud system is scaling the architecture for you. So serverless computing makes one step further, and it says, and build in response to the exact demand needed at the moment. So at the second. So this is one step further in these ideas, stop guessing capacity planning. And it's more, do not require server management. Maybe it's fine-grained deployment model where application bundled as one or more functions are uploaded to a platform and then executed, scaled, and once again, and built in response to the exact demand needed at the moment. So there are two promises. One promise is no need for infrastructure, and the cost is reduced because it scales for you. It scales up and it scales down. So application development without own server management is abstracted from this. Fine-grained development, function, or microservices. You can also use container-based serverless approaches. They are still servers, but their use is transparent to the team. Admins are still needed, but development no longer has to worry about itself. So it's also the promise, speed up development. Server provisioning, maintenance, updates, scaling, capacity planning is not needed anymore, or the needs are reduced in that field. Moving away from DevOps means, this is an idea from my side, means maybe more dev, but reduced ops. So operation is needed, but not in that deep understanding as before. Developers can concentrate on the business logic, asynchronous. So serverless approaches are always asynchronous and conditionless. These thoughts are extracted by the paper of the CNCF, the Cloud Native Computing Foundation. These thoughts are 6 years old, so it's not a new technology. It's also not a new approach, but keep in mind that GitOps and, for instance, Argo CD is also old like this, 5, 6 years. And nowadays I see in my trainings a lot of projects that are using GitOps just now. So 6 years after the start of that technology, or this idea, that thoughts how to construct pipelines. So maybe serverless has something like this in the future, will be more interesting, more advanced technologies, more standardized to use it. So there is a criticism regarding the traditional cloud computing like Kubernetes and the infrastructure you have to provide at the public cloud provider. You have a lot of descriptive configuration. You have to guess how much resources your pods need for regarding your CPU and memory and so on, networking. And you have also a lot of configurations for the infrastructure of the cloud provider, like container, firewalls, networking, and so on. And at the end, we want to focus on the application side. We want to build applications, not infrastructures. So we want to use services in an easy way. So once again, it's a slide by the CNCF, zero ops, so you don't have to care about that. Scaling to zero, so it means auto-scaling, but also scaling to zero. Kubernetes just now can't do this. Other technologies are also not able to do this, but the serverless approach, there's a promise we can fulfill this. You know, you can scale to 0 instances of your services, which means your cost reduces it to 0. But once again, your backing services are still there and you have to pay for it. If you scale to 0, you have some other problems. You must deal with this called start-up problem, which means the first request that comes into your systems needs time to start everything again, like the container, like the injection of the function, and so on and so on. So it takes time, not minutes, but it takes time. It's not so fast like if you have some services in a hot standby mode, you have to pay for it, of course, but you have to deal with this called startup problem. So use cases for serverless processing or approach is multimedia processing, database changes, IoT sensor input messages, large-scale data stream processing, chatbots, inference, of course, batch jobs and scheduled tasks, HTTP, REST APIs, and web apps, mobile backends, business logic, and so on. So a huge bunch of opportunities to use serverless approach. The CNCF say also asynchronous, concurrent, easy to parallelize into independent units of work. So you have a big task, big workload, and if you are able to separate them into distinct subtasks, they are parallelizing. So you can use a serverless approach also, or infrequent or has sporadic demand with large unpredictable variance in scaling and requirements. So just imagine you get a burst of requests into your system. You don't want to pay for all that code instances, but you want to have a system that reacts on that and starts the needed amount of instances to handle that workload. Stateless and thermal without a major need for instances, cold start time. So if your systems services, they can handle the stateless approach and they disappear after a while, you can use also the serverless approach. The fourth one here, high dynamic, in terms of changing business requirements that drive a need for accelerated developer velocity, is the promise to speed up development. And because you are just a little bit abstracted by the infrastructure and you can go to the market very fast with your ideas. So every time the serverless guys says just go up, increasing focus on business logic. If you are on the up to the serverless level, you are the winner. But I won't say you have to be careful about that, because most of the time you stick in a vendor login. So the public cloud providers likes to push you there, but be careful. So decreasing concern and control over stack implementation. So this is a drawback. If you are up to the hill, to the serverless level, you lose control about your system. The same here, it's by pivotal slide. So push as many workloads as technical feasible to the top of the pattern hierarchy. And once again, be careful. If you do an architecture and you want to use serverless approach, just figure out where it's useful, where it's a strategic goal to speed up development and so on. So be careful with this. If you have a look at the Cloud Native Computing Foundation, you find all provided technologies around serverless computing. Of course, AWS Lambda or Azure Functions, for instance. There are closed-sourced approaches, and you have also some extensions for Kubernetes, for instance, 𝗏𝗏 or Knative. About Knative, I will speak later on. 𝗏𝗏 is also an approach to automatically scale instances and also scale to 0 in a Kubernetes cluster. and you are using some application aspects, measurements like the amount of events in a queue, for instance. If the amount is too high, it will automatically start new instances to process them, for instance. The Knative is more generic. That means you don't have to do anything in the application side, but if Knative realize that too many requests comes into the system, it starts new instances to fulfill the needs of the workload. Totally transparent. There's a very interesting comparison. If you have a look afterwards to compare cloud.in, there is a comparison about every cloud portfolio which the public cloud providers support. And here's an extraction of the serverless computing area. And you see AWS has something like AWS Fargate. So this is also a serverless approach based on Kubernetes. It provides, of course, AWS Lambda, the function as a service. We will talk about that later on. And Azure has something similar, like Azure Functions, Azure Container Instances, and so on. And the Google Cloud Run, this is interesting, is an professional enterprise-based system based on Knative. So Kubernetes Knative, and you can use it in an enterprise way. And of course, it had also function as a service called Google Cloud Functions. Architecture pattern. Serverless paradigm always needs a trigger. So this can be an event. An event can also be a synchronized call like HTTP request or a Kafka message, or maybe it's an image uploaded, new order, login from user, and so on. So a lot of things you can imagine which could be an instance of a trigger for a serverless approach. And here we can see some different patterns of trigger. You can also use synchronous request response pattern. You have an API gateway in front of that, and this is responsible to call the specific function as a service in that case. So keep in mind, it's not only asynchronous calls, but the function itself is asynchronous. So some magic, some middleware should keep track on that to get the response back. You can also asynchronous message queue, like RabbitMQ. I think this is very common to use this. And of course, for the last years, Kafka or Kinesis by AWS. Kinesis is some kind of Kafka's message streaming, is perfect for using serverless patterns and maybe also function as a service. Job master work, you have a queue which is priority, you have a master. So also you can use a process engine for that, and like Camunda or something else to invoke these serverless functions. So you have a lot of different kind of patterns to fulfill your architecture in the communication way. The public cloud providers like AWS, Google, Azure, they provide their function as a service, but they also say just use the other building blocks we provide. So this is what I told you before. Be careful if you got into a vendor login, because you have to use simple queue service by AWS, or if you use Google, you have to use Cloud Firestore, and so on and so on. So you build up a whole system with the building blocks of that public cloud provider. So you don't only use the function as a service, but a whole ecosystem. So there are different types of serverless computing: backend as a service, function as a service, and Knative and other stuff. I showed you already in the CNCF slide. So backend as a service, here the idea is you don't care about the backend anymore. So which database is used, how this database is scaled up, and so on. You only have an API to communicate with this backend, and you only care about the business area on the front end level. So the backend is completely hidden to you, is transparent, is abstracted. And this is one good thing. And Firebase by Google is one framework that this supports, this approach. But there are drawbacks, of course. So unpredictable costs. So you lose control about your system. And maybe if you say the cloud provider grows with your success, so this is the problem here. What will you do if the server fails? You have no admins anymore. Vendor login again. And also you have to be careful if you have some sensible data, and you have to care about the GDPR and Patriot Act. So you have to deal with this. Where are your data? Where is your data located, in which data center? So this is very important. Function as a service is an extreme area of serverless computing. What is function as a service? I told you already, AWS Lambda, Google Cloud Function, IBM OpenWhiz, and there are a lot of more. So abstracted from server network, operation system, storage, abstracted from the developer. Billing is based on usage and accurate to the second. Function as a service is stateless. Database or file system are required to store data or state. It scales very highly. So if you have the need to scale a lot, it's the right choice to do a function as a service by a public cloud provider. You can use cloud events, and you should do this. I have here an example. I think the left one is by Google, Google Cloud Functions, and the right one is AWS Lambda. And as you see, these are functions, so it's simple. It's not a big deal to develop such functions. But what you see in the first view is they are not interchangeable. So you have a lot of imports. They are very specific to Google, and at the right side, you have a lot of imports. They're very specific to Amazon, AWS. So you can't switch the cloud provider on the level of the function as a service. It's not possible. You can maybe use the hexagonal architecture to protect your business logic from the outside of the technical level. But yeah, you have to do this, and you have to be aware that your code is maybe a little bit more difficult to understand and so on. And it's only worth to do it if your business logic and code is interesting, it's complicated, complex, and you have the requirement that you maybe shift to another cloud provider, or maybe you have an idea of multi-cloud systems. Yeah. So container versus function as a service. There are images are used for function as a service, but they are hidden. So in the most of the time, you are not aware of that. You have the cold start problem I told you before. Exactly to the second, the payment is very good. Short-lived functions, so 10 to 15 minutes. So it's not for long-living functions or long-living services. You can't use function as a service. It's forbidden. And hosting specifically, you don't want to use function as a service in the first place to migrate old monoliths, because they live only 15 minutes, and you should use containers for that if you want to. You know, you can use container even for stateful monoliths. It's not a good way to use the cloud, but it's possible. And you are limited if you use function as a service regarding the programming languages and also the framework. So I haven't seen Spring or Quarkus are using by AWS Lambda or Azure Functions and so on. So it's not possible. The reason behind this is because they use base images, they are prepared, and this approach should start and stop very quickly. So I think this is the idea behind that, and it's a simple programming approach, and you use also very simple frameworks for that. So if you have an insight of the architecture, of the left side, we see the monolith, the big whole thing. We split it up to the microservice approach, maybe using domain-driven design. Yeah, we figured out bounded context and have some qualities in mind, like performance and so on. And now we split these microservices into functions. If you don't use the cloud, if you would use an object-oriented system, we would say it's not a good idea, because you lose a lot of control, and it's like a system you can handle anymore in a good way. So our architecture is becoming more fine-grained. It is a good way to design architecture. Analogy, stored procedure. So this is a bad analogy. So it's like be careful what you're doing. It sometimes is very good because you have some needs to handle workloads, as I told you before, for big workloads and big tasks, to split them into separated tasks and so on. But don't use this as an approach for every architecture. Once again, here's an example. We discovered some nice microservices like order, and now we split the order microservices into functions, like handle payment, schedule shipment, update customer, and so on. We can do this, but once again, be careful. So it's a decomposition of application to microservices to individual functions. So pros and cons. Pros: server infrastructure is managed transparently. Focus on business requirements, faster reactions to new change requirements. Can also be an intermediate step. So once again, if you want to speed up your development, maybe you start with serverless computing, maybe with function as a service. And then if you have a good feeling that your idea, your project reach the market, the customer like your idea, you can go a step back to the traditional approach, because you get more control about your architecture, about the technique or the technology you are using, and maybe you can then shift to other cloud providers. Scalability: high scaling of only the necessary parts. So maybe you have a need for only one part, it's a problem. You can strangler it out and use it as a serverless, or maybe as a function as a service. Functions scale to 0, pay as you use, but once again, your backing system are still alive. Because of the ability to scale to 0, overall costs are reduced. Cons: poor troubleshooting. So it's a complex system. Debugging, integration testing, staging is not easy. Complex workloads are difficult to model as asynchronous loose functions. It's like always like this in the field of algorithm. As the number of functions involved increases, the complexity and predictability of the entire system increases. So the system tends to be more complex. It's harder to understand your system. Domain-driven design complied with. How do I deal with method changes? So if you are event-driven, you have also to deal with if your events are changing in time, the structure or semantic. Potentially a lot of data traffic, more than in a traditional microservice architecture, with reasonable cuts, bounded context. So you maybe increase your communication layer, and this increases also in latencies and codes. Function as a service by AWS. AWS uses a firecracker, so it's a very tiny virtual machine, which is responsible to start up very fast and stop very fast. And inside there is a container runtime like Docker or Podman, whatever, and starts a container, but it's not important for us. We only use the function code and inject this, and this will be injected for us. And this is the magic behind the Lambda by AWS, the function as a service approach. So there's no Kubernetes used there. It's only virtual machine, a container runtime, and the injection is done by AWS. So what I told you before, AWS function as a service or Lambda, it's not enough. You have to use ecosystem, and you have to use, the most of the time, an ecosystem by AWS. So requires one rich ecosystem, mixture of serverless and classic cloud native, microservice development, once again, vendor login. But maybe it's not important for you. You say it's a strategic goal to go to the AWS or Azure or Google or whatever, then it's totally okay to use all the building blocks. And as you see here, this is an example of a complex architecture. It's a customer data platform, and it's one example by Amazon to show serverless approaches in a rich architecture in a cloud-native field. So a customer data platform is a collection of software that creates a persistent, unified customer database that other systems can access. Data is pulled from multiple sources, cleaned and combined to create a single customer profile. So this is the goal of that whole project here. At the left side, you can see all the data that flows into the system. And interesting is you have a lot of traditional cloud-native building blocks are used. Only in the middle of that, AWS Lambda, there's the only serverless building block. But I think it's a good thing. We should not use serverless approaches or function as a service in the whole system, because this is not understandable and maybe also not needed. So make it easy, KISS, keep it simple and stupid. And they have decided, okay, to curate the data. So we have three levels, raw data, clean data, and curated data. And the algorithms that are curating the data are done by a serverless approach. So they don't want to have a lot of code instances, and maybe they do not need, or they do not know in the beginning how much requests will come in and how much data must be curated. So they use it, and it's a good idea to do it in this way, a function as a service way. And one very interesting step here is also they use step functions by AWS. So it's not asynchronous. Here's also state. There's a process engine like Camunda is used here to invoke these serverless functions. So it's complex, extremely many building blocks and lots of data flows, as you can see. Once again, drawback, vendor login, but if you have no problem with that, it's a good idea to build a system like this. Once again, serverless paradigm, use it only if it's useful, if you can deal with the complexity and so on. So if you have any questions, please send it to the comment space in LinkedIn. Okay, so this was an instance or example for public cloud provider for serverless computing. Knative is different. It's an extension of Kubernetes, and it's introduced by Google 2018. It's an active project. I don't think it's really used just now, but we have 305 contributors, and maybe this is a technology we will see in the future integrated in Kubernetes. Maybe not. But it's a very interesting technology to keep in mind. 𝗏𝗏, as I mentioned before, is also one technology that is an extension of Kubernetes and is able to scale pods to 0 and has a lot of advanced scaling methods to increase pods instances if the requests are too big to handle for the system. So Knative extends Kubernetes across operators. Maybe you know this already. So the operators are the area where Kubernetes can be extended. Provide support for deploying software, connecting disparate systems together, upgrading software, observing software, routing traffic, and scaling and automatically improved. So Knative is in the first place not function as a service, but you can also use it. Knative defines the service new and wants the microservice partner in the make a demand. Knative creates a defined interface between development and platform versus Kubernetes, built on top of Kubernetes, installs operators, has its own command line interface, consists of 2 basic building blocks, serving and eventing. Serving is responsible for deploying, upgrading, routing, and scaling. Eventing responsible for connecting disparate systems. So, and the Knative guys had some problem detected to the Kubernetes area. It turns out that Kubernetes, the closed loop feedback champion, has a giant gapping open loop at its heart, container placement. Once placed, a container is placed for good. So there is no strategy to place them to another part. The Kubernetes scheduler doesn't perform rebalancing, autoscaler of workloads. Rebalancing that does occur as a side effect of other causes such as container crashes or auto-scaling. So Knatives can scale the pods to 0. This is very new to the Kubernetes system. Like every time the people, they are inventing such serverless paradigms, they just go to our level, Knative level. Yeah, but it's always the same. You, once again, be careful what you're using. Knative, but Knative is an agnostic approach. So you can use Knative in every Kubernetes system. And it's open source. So they have some redefined or new terms they are using. The term service, responsible deploying, upgrading, routing, and scaling. And this is a pity because we have already the term service defined in Kubernetes as a network construct about pods. This is not a good idea. And sometimes you have problems to understand their construction. They have also a new idea of versioning services or pods. In their idea, even if the service or the pod has the same code base, so it's quite similar, but it's configured differently from the outside, from the target system. For them, these are different microservices, so they are new, and they should be dealt with as a totally different service. So this is a very new approach, idea to deal with versioning. So it's also very hard to deal with that. Here we can see one descriptive file that is used to deploy or push 2 microservices. the foo1 and foo2. These are quite similar, but configured in a different way. Maybe only one string differs. So it's already a new revision. So revision is a term here. And they have, as you see, an API, Knative API, and they redefined the term service. And if you would push this file to the Kubernetes cluster, it would start 2 microservices, and we have an implicit autoscaling. So you can explicit configure the autoscaling, but if you would use this in a plain way, you have 2 services and the traffic is splitted to 50% to each. And we have an implicit autoscaling, which means the system tries to figure out how many instances are needed to fulfill the workload or the amount of requests that comes into the system. And after the requests are fulfilled, after a while, it would be scaled to 0. So this is the core mechanism of Knative. It also provides eventing, Knative eventing. So you can also construct, besides a container-based serverless approach by Knative, event-driven architecture. And here, maybe it's very interesting that you should use Cloud Events as also a Cloud Native Computing Foundation project to standardize, to define a unified way to construct events in the system. Function as a service is also provided by Knative. And as you see here, there are more frameworks and development programming languages provided like Quarkus or even Spring Boot, TypeScript, and so on. So, but be aware of this, that the startup times are slower in comparison to the public cloud providers. They only support very stricted programming languages and frameworks. So to start up a Spring Boot application server is cost time, and it's regarding the memory you need also higher than the public cloud provider approach of function as a service. So once again, Knative services, serverless, even less contact with runtime environment, different constructed Kubernetes service, revision, autoscaling, and so on. Eventing is supported. We have a lot of strong autoscaler there. Deployment strategy through traffic splitting, rollback without downtime. It's vendor agnostic. Once again, if you have a multi-cloud approach, maybe it's a good way to use Knative or have a look at it. It's an CNCF project. It's an active community. It's open source. But yeah, you have to deal with the cold start problem. And sometimes the terms and constructions are hard to understand there. Quintessence. Serverless, again, stateless, asynchronous, short-lived in the most time, and you have to deal with the vendor login. To easily use microservices or even to do asynchronous event processing through function as a service, we need more ingredients. We need a rich ecosystems. Multi-cloud scenarios are difficult or even impossible architecture. Must deal with asynchrony, or the project must be implemented asynchronously if function as a service is to be used. Costs not only arise from the use of function as a service, but especially backend as a service. If serverless computing comes into consideration, the condition here should be clarified in order to be able to make a suitable selection of technologies and providers. Cloud is a dynamic environment. A lot is changing, of course. This is what I told you before. Maybe we see in 2-3 years more serverless approaches, more standardized at the CNCF level. I hope this will appear, especially in the serverless area. CNCF is a central place where the cloud is driven. Pay attention to the vendor login and choose your technology and architecture carefully. Thank you for listening, and I hope you have enjoyed the webinar.
Okay, I can continue to the other presentation. Okay. Okay, let's move to question and answer session. We don't have any question up till now, but you have time. If you have any question, please write as a comment, and we can answer it. And we are waiting for your questions. Okay. Let's wait a little bit. Then, if you have, okay, they have some comments. Okay. Let me ask again. Cool. Yeah. We are here for you, for your questions. Do you have any? Okay. We can wait a little bit more, and then we can move to the last part. Okay. Cool. I guess there is no question here, but if you have, you can ask during the live session, and then I can continue to the last part. First of all, thank you, Robertino, and thank you all for your participation. And I hope you found this webinar inspirational and learned something new. And I know you are waiting for the surprise, and for sure we have a surprise for our participants, for you. And for those interested in becoming an expert and obtaining certification in 𝗏𝗏𝗃, we are offering a 20% discount on all our 𝗏𝗏𝗃 courses in 2024. And you can use discount code 𝗏𝗏𝗃𝗏𝗃 to get a discount for the training suitable for you. This discount is valid until May 5th, and you make sure to take advantage of this offer. You can use this discount. And also we have another announcement, something new. If you are not sure which 𝗂𝗍𝗂𝗏 course to choose, you can check out our 𝗊𝗄𝐻 AI 𝗂𝗍𝗂𝗏 suggester. It's really new. Okay, and you can try 𝗊𝗄𝐻 AI 𝗂𝗍𝗂𝗏 suggester by clicking the link showing on the screen. I also will comment the link under the event post, and you can check it, check and try it later whenever you want. And I am also commenting. Okay, you can click the link and try it. Okay. And if you have any questions later on, feel free to reach out to us for updates on future webinars and other developments. You can continue follow us on LinkedIn, and you can also follow us on Instagram, Facebook, X, and Reddit. And again, thank you so much for your participation, and we hope to see you soon for the next webinar. And we are very thankful to be with you guys. Thank you so much. Thank you again, Robertino.
Bye-bye.
Bye-bye.